Welcome, folks. The next talk in our series of talk is Portable and Repeatable Linux Kernel with TuxMake by Vishal Bhoj and Senthil. So, TuxMate is a command line tool that eases building the Linux kernel. Though it is very simple to build Linux kernel, it becomes complicated with many other supported architecture. So let's hear it out what the folks here want to say. So let's begin with the talk.
Hello everyone, we welcome you to the talk on portable and repeatable Linux kernel builds with TuxMake in MiniDebConf India 2021. This talk will be presented by Vishal Bhoj and myself, Senthil Kumaran. We both work for Linaro Limited. Linaro is a company which started the TuxMake project. Let's get into the agenda of this talk. We'll be introducing TuxMake, and then we'll show how to install TuxMake and get the help and usage of TuxMake command line. And we'll also demo simple builds using TuxMake. And we'll also show the command execution details of TuxMake and also show how to build using containers. We'll cover on how to cross-compile the Linux kernel using TuxMake. We'll also show incremental builds and the Python interface for TuxMake. We'll touch upon contributing to TuxMake. Since TuxMake is an open source project, everyone is welcome to contribute to this project. With this agenda, we'll get into the TuxMake talk. So let me introduce TuxMake. What is TuxMake? TuxMake is an open source project from Linaro that began in May 2020 and is designed to make building Linux kernels easier. It provides a command line interface and a Python library along with a full set of curated portable build environments distributed as container images. With TuxMake, a developer can build any supported combination of target architecture, toolchain, kernel configuration, and make targets. TuxMake is based on MIT license. TuxMake was developed by Antonio Tercero, who is a long-term Debian developer, and he is also maintaining the project as of now. So more about TuxMake. First thing is, TuxMake is not about building operating system distributions. TuxMake is used for building the Linux kernel. So I want everyone to understand this difference. So we are not talking about building operating systems or the operating system distributions. TuxMake is specifically used for building Linux kernel. And you may ask, building Linux kernel is not difficult. It's easy, right? So in order to build Linux kernel, you do make defconfig make. You follow the documentation, install the dependencies, and run a couple of make commands like make defconfig and make, and then you're done. We can build Linux kernel as easy as that. However, if a developer wants to build for multiple architectures with multiple tool chains, things get complicated. Most developers and maintainers have a set of custom scripts that they have written over time and maintained to perform their required set of builds. So this is how usually Linux kernel developers solve the problem of building across different combinations. But TuxMake provides a common layer of abstraction to reduce the need for every developer to write their own build scripts. So it gives a common command line tool in order to build for multiple combinations as listed in the slide. So there are different architectures, tool chains, configurations, targets, and build time validation, which is supported by TuxMake. If you see the support matrix for TuxMake, it supports so many architectures and so many tool chains with different versions of these tool chain combinations. So building across this becomes really difficult when you want to scale to these number of combinations, which TuxMake solves for us. Let's see what TuxMake provides. So TuxMake provides a consistent command line interface in order to build Linux kernel for these multiple combinations which we saw just now. So TuxMake publishes containers for various toolchain architecture combinations as Docker or Podman container images. These containers eliminate the need for individual developers to source and install multiple toolchains and toolchain versions on their systems. So with this, TuxMake helps us to have a sandbox kind of environment in order to do your complete Linux builds. That is, doing builds within containers. It also makes builds reproducible and portable because the environment in which a Linux kernel is built is versioned and shareable across the internet and on mailing lists due to the usage of containers in which these Linux kernel are built. So there are two goals for TuxMake. Firstly, it wants to remove the friction that may cause developers, especially new developers, to skip build testing for uncommon toolchain architecture combinations when developing the Linux kernel. Secondly, to make it easier for builds and build problems to be described and reproduced. It also makes, as I said before, reproducing and reporting builds on mailing lists and different channels easier by passing on the TuxMake command, which they used for building a specific combination or a specific Linux kernel. Let's see how to install and the basic usage of TuxMake command line. Let me pull up a terminal. So as I said, TuxMake is basically a Python based command line tool. So the latest version of TuxMake is 0.13.2 and it is available via the usual Python PyPy repository. TuxMake requires Python version greater than or equal to 3.6.x. And most of you would have known how to install Python packages in your own systems. I'm just going to show you how to install TuxMake in your machines using the pip installer. So let me create a virtual environment for installing this TuxMake. So I'm creating a virtual environment with Python 3.8.4 and let me activate this virtual environment. So now I have Python 3.8.4 virtual environment. So in order to install TuxMake, I do pip install -u TuxMake. So that gets me TuxMake installed. And if I see the version of TuxMake, it is 0.13.2, which is the latest version of TuxMake. And if you want to install in your own user home directory, you need to use the -user option in order to install in a user home directory. And upgrading, as you can see, you need to use the -u in order to upgrade. So it's normal like pip installation which you do for any other Python package. As far as distribution packages are concerned, we already have the scripts in order to generate Debian and RPM packages, but we haven't published the Debian and RPM packages yet. We'll soon be adding this to the respective distributions and then make it part of Debian or other operating system distributions. So let me show you the help command of TuxMake. TuxMake has a lot of options. So as you can see here, it takes different options and different parameters in order to do Linux kernel builds. So you can pass a tool chain with which you want to build. You can pass any environment variables that you want to like pass to the Linux kernel build, and also like you can specify the different architectures you want to like support or build with. Let me show you the support matrix which this version of TuxMake supports. So it supports these architectures and these tool chains. This is how you can like see the support matrix. And similarly, if you want to like see what are the different runtimes this version of TuxMake supports, you can see this here. So it supports like Docker, Podman, and different stuff. So this is an overview on the TuxMake help command. Lot of other commands and the usage of this will be like covered by Vishal Bhoj during his demo. With this introduction, I'll pass it on to Vishal in order to like show TuxMake in action.
Hello everyone, I'll be going through a few of the demo builds using TuxMake, which will give you practical experience about TuxMake. Let's start it simple by doing a default build. Here you'll just run the TuxMake command from the kernel source tree, and it would build the kernel image for the host architecture using the host GCC toolchain. Yeah, I've triggered the build, and it'll give you a lot of it'll give you the output for each of the command that is executed. So let's go through each of them one by one. To start with, it'll give you a reproducer command. While this build happens, I can explain these output on the presentation slides itself. Yeah. Okay, the first thing which it dumps out is basically it will give you a reproducer command which you can share with others to do the same exact build. The second thing it does is basically it will create a unique build directory where all the intermediate files as well as build artifacts are stored. It would then go ahead and do a defconfig to generate, make defconfig to generate the .config file that will be used for the build. Depending on other kconfig parameters that you set, it would do other things, but yeah, let's stick to the basic build here. So it would do a defconfig to generate .config, and the next step would be it would build the default kernel image and the BZ image explicitly for x86 architecture. So first it would do a default kernel build and then explicitly trigger BZ image build, which is shown in these logs. So let's check the status of the build. Yeah, the build is still going on, so let's go back. So once the kernel BZ image is generated, it would then go ahead and build VM Linux explicitly, and then compress the VM Linux to reduce the storage space usage. In this case, it'll be a no op because VM Linux would have got built in the previous build step itself. After the VM Linux is created and compressed, it would go ahead to build the modules if the modules are enabled in the build. And it would compress the build, the modules generated from the modules install command. So let's see, I hope the build should be done. Yeah, it's complete now. So you can check, to start with, it did dump us the reproducer command, and then it went on to generate .config using the defconfig. The next was a default kernel build, and explicitly it built the BZ image. It then checks for modules if they are enabled in the .config, and based on that it would do the modules build, as well as it would then compress the generated modules into a tarball. It then checks for DTBs if there is DTBs available, it would then generate the DTBs target. But since x86 for the test fails and it says it will skip the DTB generations, it would then go ahead and build the debug kernel and then compress it. So once the build is done, it would basically provide the pass, fail, skip status for each of the targets that got built during this TuxMake invocation. So you can look at this format. It actually gives config, pass, and the duration it took for the particular stage. Finally, it would give us the output directory where the binaries are stored. The details of the toolchain version, build tools version, artifacts, and status are available in the metadata JSON. So let's go back to the build, and we can inspect the metadata file. So the build done here is the build number 20 on this particular machine. So let's go ahead and check the build artifacts. So you can see the build log will have the actual build and the logs generated during the build. It has the BZ image, config, metadata, the modules generated, and system map and VM Linux file. So let's inspect the metadata file. So this .cache TuxMake is the default location where the binaries, where the build directory is generated. So if I open the metadata file, it has different sections. So the first one is build. It gives us information about what happened during the build, the targets that were built, the architecture for which the kernel was built, toolchain, and any environment variables that are set, and any additional kconfig parameters passed, as well as the number of threads taken and if runtime was used, and the reproduce command. The next item here will be the results. It will give the results for each of the target and the duration taken for this build, and the same metadata is used on the CLI to dump the information. So the artifacts would give us the list of artifacts generated for each of the targets. So you have the log, config, kernel image, modules. Since the modules are compressed, you have the archive file mentioned here. For the debug kernel target, the VM Linux and system map are generated. It also gives us the number of errors and warnings that occurred during the build, and this can be used for statistical purposes. It will give the duration for each of the different stages which are there in part of TuxMake. Other metadata information is the kernel version, system map, VM Linux information, and the Git repository and the commit ID that went into the build. And we have the interesting bits here. It gives the complete exact version of the compiler that was used, and the version of the host OS where the build was done, and the versions of all the tools that were used during the build, GCC, make, and all the other tools which come into picture during building the kernel. Lastly, we have the artifacts section, which gives us the actual details of artifacts that were generated. In the module starball, it will list all the path for all the kernel modules that were done, and if it was DTBs, DTBs also generates an archive, and all the files present in the tarball is listed in this artifact section. So yeah, this is all about a simple default TuxMake build. TuxMake can also do the builds using the shareable environment, and this is provided by using containers. And to launch these containers, you can do it with two different runtime. One is the Docker runtime, which I hope all of us know about. The other one is Podman. Podman is a rootless, daemonless um, runtime which can be used to launch containers and do our builds. To start with, we'll just invoke the Docker runtime and tiny config build for x86. Yeah. So this will be doing an x86 64 build, but this time it will be using the Docker runtime. It will give the similar output as we saw in the first one. The first one is reproducer command, where you can see that since we use Docker runtime, it adds the Docker runtime information as well and the image that was used during this build. So here it's actually trying to pull the latest x86 64 TuxMake container. Since it's already downloaded, there was no update done during this check, and after that it will actually do the build for us. In this case, we've used an existing build directory. I'll tell you this was I'll tell you more about this in the later slides. So, that is with respect to the runtimes. We can either use Docker or Podman. The next one is cross compiling. It's similar to the x86 compilation that we showed, but it'll use cross toolchains for the build. TuxMake -target ARM64 will basically do a build for ARM64 using the cross toolchain installed on that particular machine itself. The second command is to do a build for ARM64, but the toolchain is used, which is packaged inside our TuxMake Docker container. So I'll just do the build, that way you'll get to know later. I'm doing a tiny config build just to keep this fast. And here we're using Clang 11 toolchain for the build. And now you can see it's again trying to fetch the ARM64 Clang 11. It has the Clang 11 toolchain. Sorry about that. It has the Clang 11 toolchain inside that particular container. Yes, it pulled the container and checked the SHA, and since it was already there in my machine, it did not have to pull more layers of that particular container since it was not updated. So the build is going on as expected. Let's go ahead with the next section. Yes. We've just given some more options and the way we can do with Podman as well. We'll go ahead with the Podman example in later slides. The one where I did with build directory /build will be the one where it is actually doing the incremental build. Here if you specify -build -dir the directory, it would basically do the build and store the artifact in that particular directory. And if you specify the same directory again for the next build after updating your kernel or while you're making modifications to the kernel source, it would do an incremental build. So this is happening, but that's how you do the incremental builds. The main reason why TuxMake was developed was to make it easy for users to share the way they did the build with other users, as well as some standardization for users while doing the builds, irrespective of the OS versions or the toolchain versions that may be installed on the host machine. So with TuxMake, you get user shareable build environments using containers, and it also supports kconfigs or config fragments can be provided in the form of a URL. Like you can have your own modified kconfig fragment, which you may have hosted online, and you can just specify that to TuxMake, and it would fetch that particular config fragment and use it in the build. At the same time, it would give you a reproducer command which you can share with other users, and they can reproduce that exact build using the reproducer command. And this one-line TuxMake command communicates precisely the instructions that are needed for reproducing this build. This way, if you run into any build issues, you can report it to the mailing list with just the TuxMake reproducer one-line command, and it would for other users could reproduce it easily. TuxMake can also do bit-for-bit reproducible builds, but for this you need to set other environment variables like kbuild, build timestamp, kbuild, build user, kbuild, build host, and stuff, which affect the actual kernel binary that is generated. There are other caveats also involved with reproducible kernels. More details are available in the URL mentioned here. So now we'll go ahead and do a build using Podman, and we'll use the Docker container. We'll see where we'll use Docker or Podman, and it would generate the same kernel binary with the same SHA, which is mentioned 8D066F679EAC. The final generated image will always be bit for bit identical with this particular command on any machine. So let's go ahead. This particular command is using Podman. So I've triggered the build. So let's wait for this to complete, and once it is completed, we can verify the SHA for that particular kernel image. So while that is happening, I can tell you about the containers used in the builds. The containers that are used in these builds are basically generated using Docker files, and the same are hosted in the TuxMake sources itself. The TuxMake container images are built using the standard Debian images that are provided by Docker Inc. And these containers only use the official Debian packages, and except for the toolchains that are being used for daily toolchain builds, which come from the upstream project, like the Clang Nightly toolchain, which is available. This basically gets updated on a daily basis in the upstream project, and the container gets updated on a daily basis, pulling this particular updated toolchain from the upstream project. And these containers are hosted on Docker Hub as well as AWS public ECR repository, and you could use either of those with TuxMake to do your builds. So let's go back and check. And so the build is done. Let's check them out. Yes, so let's check the SHA for the kernel image. Here you can see it is AD00F679EAC, which is the one which is mentioned in the slides. So this one was generated using the container on Docker, and the one which I did was Podman, and we get the same hash. Okay, and TuxMake also provides a Python interface for performing Linux kernel build from Python. This is extremely useful if you're building some CI system in Python and you want to include the kernel builds part of the build process. Most of the arguments are available to the build constructor build, and they are similar to the ones that are available in the CLI. So doing the build in Python would just be these three commands in Python, and based on the arguments, you can pass them in the to the build constructor. On the contribution front, the documentation is available on docs.tuxmake.org. The project itself is hosted on GitLab, and we use GitLab issues itself for tracking issues as well as feature requests. And this active community around TuxMake, so feel free to go and checking it out. The contributions for the project can be done only as merge requests on the GitLab repository itself. We have a code of conduct for the project, and you can check it out on the link under docs.tuxmake.org. The project itself is under MIT license. Yeah, on the references, I've put all the links here. Basically, it's the project as well as the documentation. There is a very good LWN article on TuxMake, which was published a couple of weeks ago. Please go check it out. And last year in LPC, there was a presentation done on TuxMake, which you guys can check out. The references has much more in-depth content as well as explanation for TuxMake, so you guys can go through them for more understanding. At this point, I want to share the link for tuxsuite.com. This is a commercial service provided by Linaro. This is built on top of TuxMake, and you can do around more than thousands of builds parallelly using our tool called TuxBuild. So this TuxSuite itself is collection of tools which allow you to build kernel in parallel in a large scale, as well as boot test them on QEMU. That is all I have. Thank you very much. We can now open up for taking questions.
Yeah. So thank you, Senthil and Vishal, for the talk. Like, I have less to no experience with the builds, but I was following along the talk, and I see like probably TuxMate would be my way into building Linux kernels. So let's have some questions from the Etherpad. So one of the question, like it's been answered on the pad also. So for the video, so it says, what is the status of including TuxMate in Debian? So Vishal or Senthil, anyone want to take that up?
Yeah, I mean, Antonio has already created the Debian packaging for that. I mean, There were two things, which is he was still thinking on whether it should go into the Debian testing, as well as since the project is very much actively developed, so making updates on Debian also would take for time for him. That's the reason he's created the packaging there, and we're still checking on where it should be hosted, and let's see. I will check with him on what the timeline should be. But if users want to create a Debian package, Senthil's posted the link for that. People can use it to create the Debian packaging.
Cool. So there is a slight out of context question, but I think you people can
Uh,
answer that.
yeah, I was about to type. The
Yeah.
question was, yeah, you can ask the question, then we
Yeah.
can.
How to port a .config that works with 5.4.x to 5.10.x when old config does not work?
Uh, I would say it would be still manual process to first do a defconfig for the 5.10 kernel and check out the old .config and go ahead and enabling the specifics which are there in the old config. It would still be a manual process, in my opinion, where you would go ahead and see which features were enabled in 5.4, and the same he would want to enable on 5.10. At the same time, if these configs had changed, that would again, that's the reason where old config wouldn't directly work, because few of them may be missing across from while the kernel changed from 5.4 to 5.10.
Sure. So I see the question was asked by Kapil. So just to add some context, Kapil had a talk like he's working porting Debian to Chromebook. So he is presently using 5.4. So he's like he want to port that 5.4 to 5.10 in that context. Yeah. Uh, Cool. Anything you want to add, and like where the people can reach you out if they want to know more, or like your emails and stuff. So where people can reach you out.
Um, yeah, we have a generic email address, tuxsuite at linaro.org. I mean, we are in the process of creating a mailing list as well for these. So that is the place. I mean, my URL, my email address is vishal.bhoj at linaro.org. So you can reach out to us, to me on that particular email address. Senthil can share his email address.
Yeah, my email address is senthil.kumaran at linaro.org, senthil dot kumaran at linaro.org. So you can reach us there. And as Vishal has pointed, like there is a website called tuxsuite.com. So you can like visit there. It has like apart from TuxMake, we also have like different products which are listed. Some of them are like kind of commercial, and which includes like TuxMake. I mean, TuxMake is completely like open source, so you can like experiment with that, and we can help you in different queries you have. So that's
Okay. So like just now I've found that TuxMate is MIT license. Okay, cool. So that works. So thank you, Senthil and Vishal, for the talk. So it's about time that we should end this talk. So thank you. Thank you.
Thank you, guys.